Hello everyone, welcome to this another lecture of theory of machines. I am Dr. Ashish Vikhar and today I am going to present the lecture on theory of machine unit number 1. Name of unit number 1 is fundamentals and types of mechanism, and today in this we will learn about point number 1.2, which is related to inversions of kinematic chains and their materials. In last video lecture I have explained to you some of the important concepts related to types of mechanism, like what do you mean by kinematic link, what do you mean by kinematic joint, what is meaning of kinematic chain, and along with that we have studied also what is machine, what is structure, and what is meant by inversion of a mechanism. This topic is related to the different inversions of kinematic chain. So let us see which are the topics. First inversion is 4-bar chain. On the basis of 4-bar chain, there are certain mechanisms which are developed are locomotive coupler, beam engine, and pantograph. Second inversion is single slider crank chain, and the examples of this is pendulum pump, rotary IC engine, oscillating cylinder engine, Whitworth quick return mechanism for shaper. Third is double slider chain or double slider crank chain, and the examples of double slider crank chain are Scotch yoke mechanism, elliptical trammel, and Oldham's coupling. So first inversion is 4-bar chain, and in that you will study the structure of locomotive coupler, beam engine, and pantograph. Second one is single slider crank chain, in which you will study pendulum pump, rotary IC engine, oscillating cylinder engine, Whitworth quick return mechanism. And third inversion is double slider crank chain, in which you will study Scotch yoke mechanism, elliptical trammel, and Oldham's coupling. Particularly in this today's lecture, we will see only about 4-bar chain and the structures of locomotive coupler, the mechanism of beam engine, and pantograph. Let us see what is the meaning of 4-bar chain. The structure or the sketch of 4-bar chain you will see in this figure. You will see clearly here there is a moving pivot at the upper level of fixed pivot. There are fixed pivot you will see, and there are two moving pivot that you can watch here. So number one is the 4-bar mechanism is one of the important kinematic chain. It looks like a cycle frame. So 4-bar chain mechanism is also known as quadric cycle chain. 4-bar chain has a 4 links, in which 3 are movable links and 1 is fixed link. Each of these links will form one turning pair. These 4 links can be of different length. So this is the important point related to 4-bar chain. 4-bar link, it is having 4 links, means 4-bar chain is having 4 links, in which there are 3 movable links and 1 is a fixed link. So each of these links will form a turning pair. We have seen what are the different types of pair: sliding pair, turning pair, spherical pair, screw pair. Out of that, in case of 4-bar chain, you will see every link will form one turning pair. A 4-bar chain is a linkage of 4 pivots, 2 of which are fixed. The bed or surface they are fixed may be regarded as the 4-bar or a link. So this is nothing but regarding the pivot. So 4 pivots are there, out of which 2 of are fixed, and in this way we can have a moving pivot and a fixed pivot, 2 fixed pivot and 2 moving pivot, as you can see in this sketch. So let us see again the meaning of inversion. By fixing each link at a time, we get as many mechanism as the number of links. Then each mechanism is called inversion of the original kinematic chain. In 4-bar chain, there are 4 links in which there are movable links, and one is there are 3 movable links and one is a fixed link. So which are the inversions of 4-bar chain? Number 1 inversion is called beam engine. Beam engine is also called as crank and lever mechanism. Second inversion is locomotive coupler, which is also called double crank mechanism, and third inversion is called pantograph. So let us see first inversion, beam engine, which is also called as a crank and lever mechanism. What is the purpose of beam engine? Beam engine is used to convert the rotary motion into the reciprocating motion. You will see here the sketch of beam engine and crank and lever mechanism. So crank and lever, these are the two important components. You will see that link 4 is nothing but a lever, and link 2 is nothing but the crank at the point number A. So you will see that link number 1 is frame, link number 2 is nothing but crank, link number 3 is connecting rod, and link number 4 is nothing but a lever. So out of this you will see that frame, which is called as a link number 1, is fixed. So these are nothing but the important parts of the beam engine. Which are that important part? Number 1 is frame, which is fixed and which is also called as a fixed link. Number 2 is called crank. Number 3 is connecting rod. Number 4 is lever. Lever is also called as an rocker. Let us see how it works. It consists of 4 links. When the crank rotates about a fixed center A, the lever oscillates about a fixed center D. So there are 2 fixed centers, one is at A and another is at D. So when the crank rotates about a fixed center A, what will happen? The lever oscillates about a fixed center D. The end E of the lever CDE, so total lever is CDE, and the end E of that lever is connected to the position rod. You will see that position rod in the sketch, which reciprocates due to the rotation of the crank. So there is a rotation of the crank, and because of that the position rod will reciprocate. So this way, to convert the rotary motion of the crank into the reciprocating motion of the piston rod, a beam engine can be utilized. So this is nothing but the first example of 4-bar chain. Second example is locomotive coupler. It is also called as a double crank mechanism. What is the purpose of locomotive coupler? The locomotive coupler or double crank mechanism is used to transmit rotary motion from one wheel to the other wheel, which helps in moving the vehicle. Such type of application that you will found in railway engines. So this is a sketch of a locomotive coupler. You will see that all the components, you will see again here fixed link is L1, there is a crankshaft L2, connecting rod L3 and crankshaft L4. So there are 2 crankshafts, one connecting rod and one fixed link. Let us see that. Number 1, and the number 1 is frame, which is called as a fixed link, link number 1. Number 2 is crankshaft or driving crank, that is called link number 2. Number 3 is connecting rod, which is nothing but link number 3, and crankshaft, which is called as a driven crank, that is called link number 4. So driving crank is crankshaft link number 2 and driven crank is crankshaft link number 4. The mechanism of locomotive coupler contains 4 links, which are, as you can see in this picture, AB, BC, CD and AD. So these are nothing but 4 links. In this link, AB link is fixed, A to B, that is the link, and this is a fixed link. Both AD and BC acts as a crank, and link CD acts as a coupling rod. That's why it is called as a locomotive coupler. Fixed link of AB maintains constant distance from one center of the circle to next center of the circle. So this is the nature of working of locomotive coupler. Let us see third example, pantograph. So you will see in this picture the pantograph. What is the purpose of pantograph? To reproduce some motion exactly either to a reduced scale or on an enlarged scale. So you can see in this picture there is a in the form of somewhat enlarged scale, and below to that on left hand side you will see the same picture into the reduced scale. So this is a structure of pantograph. So which are the important parts? You will see here, number 1 is a link AB, and A is fixed. Link BC, you will see the BC. After that, third is nothing but third important component, that is nothing but link DE, and fourth important component is link DF. So link DE and link DF, these are the another links inside the pantograph. This mechanism is an inversion of 4-bar chain. It has 4 turning pairs. One link is fixed to the table. You will see link AB is there and end A is fixed. The stylus is attached to the junction of link DE. You will see that link DE, and to that a stylus, a pencil is attached, and DF and the pen is attached to the C of the link BC. You will see that link BC, and at point C the pen is attached. The length of all the links are adjustable through the holes provided on the links. So you will see that dotted spots on these links, and we can get different links adjustable through the holes provided on the links. We can get a different length. As the operator traces the drawing with the stylus, the same drawing is reproduced by the pen either in enlarged or reduced scale depending upon the link length. The link have holes for the adjustment of magnitude of enlargement or reduction. So this is the third inversion of 4-bar chain. So in this you will see that there are 4 turning pairs. Turning pair number 1 is AB and BC. AB and BC, this is the first turning pair. Turning pair AB and DE. Turning pair AB and DE. This is nothing but second turning pair. Third turning pair is BC and DF. BC and DF. These are the third turning pair, and fourth turning pair is ED and DF. So 4 turning pairs you will form in this application of 4-bar chain, which is called as a pantograph. So what are the applications of pantograph? Number 1 is for reducing large drawing, and number 2 is used in electric train supply system on top of the train, which supplies current to electric train from cables on the top. You might have seen this mechanism at the top of electric engine of the electric train. And after that we will learn about inversion of single slider crank mechanism. It has 5 inversions. Let us see one by one. The 5th inversion is Whitworth quick return mechanism. 4th is crank and slotted quick return mechanism. 3rd is oscillating cylinder engine. 2nd is rotary IC engine. and number 1 is pendulum pump or bull engine. So, all these that we will see one by one in the next lecture. We will meet again. Thank you.